So very good afternoon, students. So welcome to IIT NEET Foundation Program or Focus C by Krishnaveni Talent Schools and Mastermind Schools. So once again, welcome all the class 9 students for today's session, both KTS Jogipet and Gudi Malkapur so far. So as you all can see on the screen and you are well aware, my subject is physics. We are in class 9th, our ongoing chapter, work, energy and power. And today we are entering into the last session, third session of the chapter in completing complete concepts. So before going for today's session directly, let us recall what we learned in the earlier classes. So if you remember, we completed about the work and energy part, right? So we are done with the what is work, right? What are the types of works? Correct. Then we enter into the energy. What is energy? So types of energies where you can come across kinetic energy and potential energy, which is given by half mv square and mgh. Here types of works also we have positive work, negative work and zero work also. Three types of works are there. Right. So we also discussed about work energy, relation to work energy, that is work energy theorem in last class. That is work done is equal to change in kinetic energy of V2 square minus half V1 square. Is a statement for the work energy theorem. So with this completely aware about the, and of course we discuss about the various forms of energies, not only types. These two types contain so many forms like solar energy, magnetic energy, electric energy, light energy, heat energy, nuclear energy, tidal energy, wave energy. So many types of energies are available for us. So all the forms we have seen with the colorful pictures and all. Right. So this part we have done. And we are clear about the work and energy. Then the third one is power. So all three are, I told already in the beginning, all three are connected to one another. Work is when the body displaces, when the force is applied. Energy is the capacity of doing work. But power is the rate of work done. How fast you are doing the work. Rate. Rate is not cost. Rate is not speed. If you do the same work with very speed, suppose I give one question for you to read and tell her. One student will complete in 5 minutes, second will take in 10 minutes, third will take 15 minutes. Everybody will learn the answer. But how fast you are learning is important. It makes you intelligent. Similarly, power also. How fast you can do the work is called power. So we'll discuss about the power in details and what is power, what are the units of power, everything. But before that, glance you can see here what is the definition of work. F is equal to W is equal to F into S formula. Then we have seen the units of work, joule or erg. Then there is a positive work done, negative work done, and zero work. Positive work is when the work is done, the body displaces along the direction of force. If the body displaces other direction, maybe make angle. Force may be making some angle with the displacement is called negative work. F into S cos theta. When either force applied is zero or displacement is zero, the work done also zero. Right. Then work done against the gravity also very important, negative work. When you are lifting the body up against the gravitational force, then the work done is called negative work, or that is also comes under potential energy. Okay. Now we are seeing kinetic energy. Every moving body possesses energy called kinetic. The energy possessed by a body in motion is kinetic energy. Energy possessed by body at position is potential energy. So like that we discussed about the both potential and kinetic energy. Right. Okay. Then we discussed about derivation for kinetic energy as half mv square. Then work energy theorem we have seen yesterday. The work done is equal to the change in kinetic energy. That is W is equal to half mv1 square minus mv2 square, mv2 square minus mv1 square. Already we given the derivation also for that. Now these are the types of energies where we can see different forms. Right? Different forms of energies where we come across. Like, see, electric energy, thermal energy, light energy, wave energy, heat energy, hydroelectric energy. Hydro means water. Solar energy, wind energy, nuclear energy, tidal energy, biomass energy, kinetic energy, geothermal energy, heat from the earth. Geo means earth. So not only that, there are some more are there physics. In physics, there are two types of energies are there, kinetic energy and potential. In kinetic, you come across mechanical energy, electric energy, thermal energy, radiant energy, and sound energy. Others like chemical energy, nuclear energy, gravitational energy, all this elastic energy all comes under potential energies. Okay, clear? Na? Now some more are there. 10 forms of energies, beautiful color pictures. We can grab your attraction. I collected them. Kinetic, potential, sound, mechanical, elastic, radiant, chemical, electric, nuclear, and heat. These are the various forms of energies which we use in our day-to-day life. Right? So this you can make a big project also, you can correct them. How many types of potential energies are there? How many types of kinetic energies? You can prepare a chart as your project work, and you can display in your classroom, or during the PTMs you can show to the parents, or during science space you can show them. So various forms of energy will come across in our daily applications. There are 10 forms are there. So before going for the power, what is power? What is the formula of power? What are the units? So I'll show a video for you where you can know clear picture about our chapter. Right? Once again, you can see this video where you can enjoy come to know about what is energy, what is power.
Production.
I have to do lots of work. I'm so tired. I don't have any more energy now.
Mom, why do you need energy?
Son, we do lots of work daily. Reading, writing, thinking, cycling, etc. So we need energy to do all these activities.
Mom, this washing machine also does work. Does this also need energy?
Yes, but there's a difference. Come, I will tell you about the work and the energy.
Objectives. At the end of this lesson, you'll be able to define work and energy, write different forms of energy, write the expression for kinetic and potential energy, understand the laws of conservation of energy, define power, write the units of work, energy, and power.
So entire chapter you can learn about everything.
Work. Friends, we do lots of work like playing, studying, cycling, running, etc. All these works require a lot of energy. But the scientific definition of hard work may involve very little work. Let's see how. Look at this huge truck. We work hard to push it, but the truck does not move despite all the effort. We get tired. However, we have not done any work on the truck as there is no displacement of the truck. We can say that we did hard work, but in science, the work is not done on the truck.
Because it's not moved. As is truck.
We use and define the term work differently in science. For example, if we climb up a cliff, then according to science, we have done lots of work. scientific conception of work. For work to be done, these two conditions should be satisfied. First is, a force should act on an object. Second is, the object must be displaced.
Should move.
Let's take a look at a few situations. If we pull a table and the table moves through a distance, here we have exerted a force on the table and it is displaced. So both the conditions are satisfied here. Therefore, work is done. Similarly, while playing cricket, if we hit a ball with a bat, then work is done because force is exerted on the ball and that ball is displaced. Work done by a constant force. To understand the concept of work in science, let us consider a case. Case is, the force is acting in the direction of displacement. Let a constant force F act on an object. Let the object be displaced through a distance S in the direction of the force. Let W be the work done. We define work to be equal to the product of the force and displacement. Work done is equal to force into displacement, or W is equal to F into S. Thus, work done by force acting on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of the force. Work has only magnitude and no direction.
It's a scalar.
If F is equal to 1n and S is equal to 1m,
1n is
then the
Newton,
work done
m
by
is
the
meter.
force will be 1 Nm. The unit of work is Newton meter or joule. Thus, 1 Newton meter or 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. Example. Let's now find the work done when force applied and displacement is given. A student lifts his school bag from the ground and puts it on his shoulders, 1.5 meter above the ground. A force of 5 Newton is acting on an object. Calculate the work done by him on the school bag.
7.5 Newton.
We can see that here force applied is 5 Newton and displacement S is 1.5 meter. We know that work done is equal to force into displacement. Therefore, we get work done is equal to 7.5 Newton meter or 7.5 joule. Energy. We now know
Nothing
that
done.
to do any kind of work, we need energy. We must have energy to accomplish work, but the question is, where does this energy come from? The sun is the biggest natural source of energy to us. Many of our energy sources are derived from the sun. Energy sources are classified into two groups, non-renewable and renewable. Most of our energy comes from non-renewable energy sources. Coal, petroleum, natural gas, propane, and uranium are non-renewable energy sources. They are used to make electricity, to heat our homes, to move our cars, and to manufacture all kinds of products. These energy sources are called non-renewable because their supplies are limited. Renewable energy sources include biomass, geothermal
You
energy,
have seen the names of all.
hydropower, solar energy, and wind energy. They are called renewable energy sources because they are replenished in a short time. We use renewable energy sources mainly to make electricity. An object having a capability to do work is said to possess energy. The object which does the work loses energy, and the object on which the work is done gains energy. The energy possessed by an object is thus measured in terms of its capacity of doing work. The unit of energy is, therefore, the same as that of work, that is, joule. 1 joule is the energy required to do 1 joule of work. Sometimes a larger unit of energy called kilojoule is used. 1 kilojoule equals 1000 joules.
So energy this is. Till there,
यार सेंसे
मैं इतने लोगों का फॉलो
then we
करता
can come across the
हूँ. I don't have any
power
followers.
Forms of energy.
various.
There are many different forms of energies. These various forms include potential energy, kinetic energy, heat energy, chemical energy, electrical energy, and light energy. Let us first study about kinetic energy. We know that a moving object can do work, and an object moving faster can do more work than an identical object moving relatively slow. Kinetic energy is the energy possessed by an object due to its motion. The kinetic energy of an object increases with its speed. Turning wheel, moving car, boy running are the examples of kinetic energy. So we say that the kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it acquire that velocity.
So after forms of energy, again we have the about power also they'll explain, right?
Equation of kinetic energy. Let us now express the kinetic energy of an object in the form of an equation. Consider an object of mass m moving with a uniform velocity u. Let it now be displaced through a distance s when a constant force F acts on it in the direction of its displacement. We know that the work done W is Fs. The work done on the object will cause a change in its velocity. Let its velocity change from u to v. Let A be the acceleration produced. The relation connecting the initial velocity u and final velocity v of an object moving with a uniform acceleration a
Yeah.
and the
Clear.
displacement s is v square minus u square equal to 2as. This gives s is equal to v square minus u square whole upon 2a. We know that f is equal to ma, so by using values of f and s in the equation of work, we get w is equal to ma into v square minus u square whole upon 2a. Or we can write it as w is equal to 1 upon 2 into m into v square minus u square. If the object is starting from its stationary position, this is u is equal to 0, then the work done, w is equal to 1 upon 2 into mv square. It is clear that the work done is equal to the change in the kinetic energy of an object. Thus, the kinetic energy possessed by an object of mass m and moving with a uniform velocity v is 1 upon 2 mv square.
Yes. That is half mv square is the kinetic energy formula. Right. Now they explain the remaining.
Example. Let's now find the kinetic energy of an object of mass 10 kg which is moving with a uniform velocity of 4 meter per second. Solution. Here mass of the object m is equal to 10 kilogram. Velocity of the object v is equal to 4 meter per second. From equation of kinetic energy we get 1 upon 2 into 10 kilogram into 4 meter per second into 4 meter per second, which is equal to 80 joules. Hence, the kinetic energy of the object is 80 joules.
Simple example. Simple calculation by using the formula half mv square. So everything is covered here.
Potential energy.
So you will get it.
To understand potential energy, let's do an activity. Take a rubber band, hold it at one end and pull from the other. You will see that the band stretches. Now release the band at one of the ends. What do you see? The band will tend to regain its original length. This means that the band had acquired energy in its stretched position. Do you know how did it acquire energy when stretched? Here the energy gets stored due to the work done on the object. The energy transferred to an object is stored as potential energy if it is not used to cause a change in the velocity or speed of the object. We transfer energy when we stretch a rubber band. The energy transferred to the band is its potential energy. The potential energy possessed by the object is the energy present in it by virtue of its position or configuration. Potential energy of an object at a height. Gravitational potential energy is the energy stored in an object as the result of its vertical position or height. Let's find out the expression for the gravitational potential energy of an object at a height. Consider an object of mass m. Let it be raised through a height h from the ground. A force is required to do this. The minimum force required to raise the object is equal to the weight of the object. The object gains energy equal to the work done on it. Let the work done on the object against gravity be W. That is, work done, W, is equal to force into displacement, which is equal to mg into h, which is equal to mgh. Since work done on the object is equal to mgh, and energy equal to mgh units is gained by the object. This is the potential energy of the object. Also, the work done by gravity depends on the difference in vertical heights of the initial and final positions of the object, and not on the path along which the object is moved. Conversion of energy. Answer one question now. Can we convert energy from one form to another? Yes, one form of energy can be converted into another form. Let's take a small example. When we switch on a bulb, the electric energy is converted into light energy. Similarly, when we plug on the TV, the electric energy converts into heat energy, sound energy, and light energy. Laws of conservation of energy. We now know that the form of energy can be changed from one form to another. Whenever energy gets transformed, the total energy remains unchanged. This is the law of conservation of energy. According to this law, energy can only be converted from one form to another.
Very big video and
It
very
can neither be
video also.
created nor be destroyed. The total energy before and after the transformation remains the same. Let us consider a simple example. Let an object of mass m be made to fall freely from a height h. At the start, the potential energy is mgh and kinetic energy is 0. Why is the kinetic energy 0? It is 0 because its velocity is 0. The total energy of the object is thus mgh. As it falls, its potential energy will change into kinetic energy. If v is the velocity of the object at a given instant, the kinetic energy would be 1 upon 2 mv square. As the fall of the object continues, the potential energy would decrease while the kinetic energy would increase. When the object is about to reach the ground, h is equal to 0 and v will be the highest. Therefore, the kinetic energy would be the largest and potential energy the least. However, the sum of the potential energy and kinetic energy of the object would be the same at all points. That is, potential energy plus kinetic energy is equal to constant.
Okay, anyway, there's a big one is there. I don't think so. It is comes to the PowerPoint. Anything comes
5 मिनट में मिलेगा वरना 50 रुपए आपके
just a minute. If anything
1 meter. An object having capability to do work is said to possess energy. Energy has the same unit.
Okay, anyway, so big one. We got a complete picture about the what is the work, energy, and types of energies. Now, when it comes to power, already I told the rate at which work is done means rate means fast. how fast you are doing work is called as power. That is, power is equal to work by time, W by T. P is the power, W is the work done, and T is the time. So unit are, work is measured in joule. So work is measured in joule and time is measured in second. Joule by second is the unit, or you can write as watt. Is the unit of power. Okay. So power is nothing but rate of work done or work done in a given time, which is measured in either joule per second or watt. So other units also, there's so many units like kilowatt. Kilo means 1000 watts. So generally in case of vehicles, they use the horsepower. Very important. One watt, kilowatt is 1000 watt. 1 horsepower is 746 watt. Very important. 1 HP. For engines, we'll use as a car or two-wheelers. That HP is nothing but horsepower. 1 horsepower is equal to 746 watt. Then again, erg per second is another unit in CGS system, which is nothing but 10 power 7. 1 watt is equal to 10 power 7. 10 power 7, this is erg per second. And another unit is BTU, British Thermal Unit, right? Which is equal to 1 watt is equal to 3.412 BTU. There is a conversions for the power. You can use power in the either joule per second or erg per second, or you can use in the BTUs, right? So these are about a simple explanation about the power, which is rate of work done in a given time. How fast you are doing work is nothing but power, right? So this is totally about the chapter. Now it's your turn. Now it's your turn to go through the material and complete the worksheets and get ready for the exam tomorrow. Tomorrow you have prepared well, and Monday you can appear for the exam with full confidence, right? So that's all for today. You can write, there is no homework. Homework you mentioned as a revision for test 5, or revise the materials worksheets, right? So thank you very much, all of you. Have a wonderful day. Thank you.